Part 3 of my fraction videos. Hi, my name is JuanTutors. My goal is to get you the highest grade on the ACT so that you can get into the college of your choice and get the career you deserve. One of the topics that's way overlooked for students that are taking the ACT and SAT, by the way, is how to work with fractions. The SATs and ACTs love asking about fractions, not even because they really expect you to know a lot of things about them. You can get away with a lot of that with your calculator, but because it differentiates the high-level students from the level right below it. So if you don't know your fractions, you can actually lose a whole lot of points just because they want to separate you from everyone else. But on the other side of it, if you know your fractions, you can actually get to a higher level almost for free. Remember, nerd is a compliment and nerds take notes, so get your notebooks out and take notes. Here's a quick question. Do you remember the definition of rational numbers? There's two of them. Here's the definitions from our previous video. Here's a clip from our most recent video on that question. Two definitions of rational numbers. One, a rational number is a number that can be written as a ratio of two integers. Another definition, different definition. A rational number is a number that can be written as a terminating or repeating pattern decimal. In the previous video, we learned that to convert a fraction into a decimal, all you have to do is recognize that that fraction bar is a division, so you perform that division, and that fraction is converted into a decimal. 11 over 7, do 11 divided by 7, and you get a repeating pattern decimal. 7 over 8, that is a terminating decimal. You do 7 divided by 8 and you get a terminating decimal. What about if we need to go the other way around though? I think this is a really cool problem because it actually involves algebra. You can convert a decimal repeating pattern or terminating decimal into a fraction. The two problems are slightly different. I wonder if you'll see why. And by the way, both the SAT and the ACT expect you to know how to be able to do this. So definitely this video is for you. Keep watching. Take notes. Here's the first example. We want to convert 27.08 into a fraction. 0.8. What did 0 say to 8? Nice belt. So how do we convert this into a fraction? We let x be 27.08. So our goal is to convert x into a fraction. This is a terminating decimal, so what we do, we multiply by a power of 10 to eliminate the decimal part. In this case, if we move the decimal place over to the right 2 spaces, the decimal place is eliminated. To do that, we multiply by 100. We get 100x is 2,708. Then we solve for x. We divide by 100 and we get x is equal to 2708 over 100. That's the fraction. If you need to reduce, great. If you don't, you're done. You can reduce on paper by dividing the numerator and denominator by 4. That's the greatest common factor of 2708 and 100. Or you could perform this reduction on the calculator. And for the SAT and ACT, I actually recommend you do that because it's a lot more efficient, it's a lot faster, and there's a whole lot of situations which the fraction doesn't reduce and you waste a lot of time trying to find the reduction. Let's do the second one, and I think this is a really cool one because this is a repeating pattern decimal. Convert 7.132 bar into a fraction. Now notice the bar is over the 32, it's not over the 1, so the 32 is the part that repeats. So this is 7.1323232, etc. I invite you to think about why is it that we can't convert x into a fraction the same exact way that we converted the other one. So what do here? We multiply by a power of 10 to eliminate the non-repeating part. The only non-repeating part is that 1. So we multiply by 10 to move the decimal place over 1 space. We get 10x is equal to 71.32 bar. So 71.32323232. Now we multiply by a power of 10 again so that the repeating part of the new decimal is the same as the repeating part in this decimal. This number has a repeating decimal of 32. To move the decimal place over 2 spaces, we multiply by 100. So we get 1000x is equal to 7,132.32 repeating. And it might seem like we're so far away from the solution at this point, but we're actually right there. If we subtract those two lines from each other, we're basically done. So we subtract 1000x minus 10x, that's 990x, and we subtract 7132.32 repeating minus 71.32 repeating. And notice the decimal part, all the decimals cancel. So you're left with 7,061. And at that point, you just solve for x. Divide by 990, and we get x is equal to 7061 over 990. And that's the fraction form of this decimal. We use the calculator to determine if this fraction can be reduced, and we find out that it can't. We would have wasted a lot of time looking for a way to reduce this fraction, but in fact, we're done. 71.32 repeating is equal to 7,061 over 990. By doing this, we've actually created an algorithm that converts every terminating decimal into a fraction and every repeating pattern decimal into a fraction. So this shows that every terminating or repeating pattern decimal can in fact be written as a ratio of two integers, so they are rational. So the two definitions are now equivalent. If you want to watch one of the previous videos on the series or any other video that we made, click on one of the videos on the left. And if you want to subscribe so that we can get you on track to getting a perfect grade on the ACT, which would be great, click the subscribe button below, and I'll see you in the next video.